We're going to take a look at this next one. This is 8.2, number 20. And so there are three parts to this. And the first question is, what is the period for the graph shown above? Well, I can see here. I can see here. It looks like it's going from negative pi to pi. That's a full period. I mean, we could try to find others, but that captures all the values without overlapping. So that is a period of 2 pi. So it's a 2 pi period. And then it says, what is the vertical stretch for the graph shown above? So let's just take a look at that part. Now, what might be helpful is to compare this to, this is either going to be, it could be a y equals secant x or y equals cosecant x. So I have here on this other screen, let me see if I can find it there, I have a cosecant and a secant. So we can really choose either, and we can always shift a function if we wanted to, but if we want to keep it as simple as possible, here's a secant, and notice the secant has a vertical asymptotes at negative pi over 2 and 3 pi over 2. So we can treat it as a shifted secant, or if we look at cosecant, well, that's going to have a vertical asymptote at negative pi to pi. So this one actually fits the mold better without doing any kind of shifting. However, if you noticed, the one we had before had our vertical parts over here, negative pi to 0, and the lower parts, the above the x-axis parts from negative pi to 0, and the below the x-axis is 0 to pi. So we may have to do a negative leading coefficient when it comes to the stretch. The second thing I want to highlight is that notice that the lowest the upper part comes to is positive 1, and the highest the lowest part comes to is negative 1. Now if we go back to the graph we're talking about, so it should be down here, should be coming up, well, normally it would be coming down to 1 and up to negative 1. So obviously we're going to have an issue with that, which will just go, if I'm going to focus on cosecant, we'll go with y equals negative something cosecant x plus possibly something. Now notice I'm just leaving it as cosecant x, and I'm not going with a coefficient because the period is 2 pi, which is the standard period for a cosecant function. So we don't have to worry about changing that period, having it a b other than 1. Okay, so let's talk about two things. One, obviously this is up higher than it should be. This is also up higher than it should be. So that indicates a vertical shift. Also, what I want to point out is in our standard cosecant function, from the bottom of the top of the high part and the top of the low part is normally 2. Now how far are we? We're from 4 to 0. So we're seeing obviously a stretch as well as a vertical shift. So I'm going to propose a couple things. One, this vertical shift, this should be done here at negative 1. This should also be down here at 1. But what would first apply would be the stretch and then the shift. So thinking about that, what do we say? It's normally from the high, from the bottom of the top to the top of the bottom, if that makes any sense. Should be 2. Yeah, should be 2. In this case, it's 4. So that means there's a stretch of 2. Now I can use that stretch of 2. Now let's also just think about this for a second. It's a stretch of 2. Also, it should be up here, but it's down low. That means it has a vertical flipping or reflection. So I'm going to go with a -2 for the stretch because it reflects it and then stretches it. Now, if that was the case, it would have been down here and there. Well, sorry, there. But we have this distance now, and this distance. So they're both pushed up by 2, so there'd be a vertical shift by 2. So I'm going to say +2. So the answer should be y equals -2 cosecant x plus 2. -2, negative because it's flipped, 2 because it was stretched by a factor of 2, which was, the student got correct there, and then +2 was the vertical shifting of that one. So a little bit complicated there. Sometimes you got to play around with the numbers a little bit, but you can look at, I mean, you can play with this on Desmos if you wanted to. Like if I went back to Desmos and said y equals -2, so I could delete the whole thing, -2 cosecant x plus 2, and I don't know what just happened to everything. Oh, I turned it off there. There's our graph. Okay. Compared to a standard graph of y equals just cosecant x. So you can see how the green should be here. It's been flipped over. That accounts for the negative. And then for the stretch, imagine this going up to 2, this going down by 2. So just throw a 2 in there. You can see that they got stretched up, that got stretched down. Then a +2 then moves it up into position. Then putting a negative out front flips them so they line up on top of each other. So hopefully that shows kind of an evolution or a development into that function. Sorry, this has been a little bit long video.